Okay, I came from Bali. As you can see that Bali is a very beautiful island in Indonesia, which is famous for its beautiful beaches and also for the seafood restaurant. So, one day, when I went to one of the biggest seafood restaurants in Bali, I saw there's a lot of seafood waste there. Well, you can imagine that there might be hundreds of seafood restaurants in Bali. Then how many waste they will produce? At that moment, I just think that I would like to change this waste into something useful for other people, but I don't know how. So I start to browse the internet and I find that most of this waste contains chitin. My name is Bastian from Indonesia, and I proudly present my research entitled Sila-Serata as Bioplastic. I believe that every of us ever went for shopping, and sometimes when we buy a lot of things, we have to carry it using plastic bags. But suddenly, this thing happens. The plastic tear off, and everything inside it starts to fall out. Well, I also experienced this kind of problem. Each year at my school, I will get a lot of new books, and I have to carry it home using plastic bags. But unfortunately, I never managed to bring it home. The plastic always torn off halfway home. So here, we have two problems. The first one is that there are not many known methods to utilize the abundant crab shell waste. And the second one, there's a great need of strong plastic and also strong eco-friendly plastic. To understand more about the research, first we have to understand some main materials in the research. The first one is the crab shell. This is the content of the crab shell. In this research, I utilize chitin from the crab shell. Chitin is the most abundant biopolymer in the ocean. Basically, chitin is cellulose, but with one hydroxyl group in its monomer replaced with acetylamine group. The next one is the low-density polyethylene that will represent synthetic plastic groups. Low-density polyethylene is the first grade of polyethylene that has low intermolecular forces and also low tensile strength. And the last one is the cassava starch-based plastic that will represent the organic polymer. Well, this is a plastic that mainly composed of cassava starch and vegetable oil. It is not water resistant. The solubility in water is 200 grams per liter, and it will be degraded into carbon dioxide, water, and biomass after 3 to 6 months of disposal. And these are the equipment in my research. And these are the materials. So this is the workflow of the experiment, the design. First, the dried crab shell waste, grind it, and we obtain the crab shell powder. And after that, we extract chitin from the crab shell powder. In this research, I'm using two different extraction methods. The first one is the modification of conventional chitin extraction method. Consists of demineralization, deprotonation, and decolorization process. Well, the result is from 1 kilogram of crab shell powder, I obtain about 89.2 grams of chitin extract in solid state. Well, we can see that it's 8.92%, but the expectation is 19 to 32%. So the result is still far below the expectation. Here's how it looks like, the solid extract. The second extraction method is a self-designed extraction method performed by dissolving the crab shell powder in calcium chloride and methanol. The result is from 50 grams of crab shell powder, I obtain about 50 milliliters of chitin extract in liquid state. Here is how it looks like. It has brown color. The existence of chitin in the extract proven by FTIR spectrophotometry test and dissolution test. Here is the IR spectrophotometry result. If we compare both spectrum of the extract with the one from the literature, well, we can see that it's not exactly the same, but it has similarities. Therefore, it can be concluded that the extract contains chitin, but the extracts are not pure chitin. For the dissolution test, I perform it to the solid extract, the extract from the first extraction method, and I try to dissolve it in acetic acid 1%, 2%, and glacial acetic acid. Well, here's the result. You can see that the extract is best dissolved in acetic acid 2%, and about 40 to 50% of the extract are chitin, so it's not pure chitin. The next step is the mixing and molding. Here we will have two final products resulting, the bioplastic and the biodegradable plastic. Oh, sorry. The bioplastic and the biodegradable plastic. Bioplastic is the mixture of melted LDPE with chitin solution in acetic acid 2% that molded manually on a flat surface. And I try to mix it with 4 different ratios. Here's the sample picture of the bioplastic product. And I also try to mix the chitin extract from the second extraction method, the liquid one, with LDPE, but only with 1:1 ratio, because as you can see that the result is not very good. It has brown color, and it actually produces brown mucus, and it has very bad odor. Therefore, it can be concluded that this bioplastic won't qualify for further testing. The biodegradable plastic is the mixture of cassava plastic dissolved in water with chitin solution dissolved in acetic acid 2% and cast it in a petri dish and dried in the oven. Well, this is the sample picture of the biodegradable plastic product. And I also try to mix it with 4 different ratios. After all bioplastic and biodegradable plastic samples obtained, I measure the tensile strength and the elasticity of the plastics using autograph. All samples were cut into 5 times 1 centimeter size, and I also try to do my best to make all samples have the same thickness and surface flatness. Well, here's the result of the autograph test for bioplastic products. For the tensile strength, we can see that 122 provides the best result. It is 184.5 Newton, while the control is only 80 Newton. And for the elongation, we can see that 122 still provides the best result. It is 4.9 millimeters, while the control is only 2.23 millimeters. Autograph tests for biodegradable plastics products performed in 2 different conditions. The first one is in original state, and the second one is after being dipped in water for 5 minutes and then washed using dry cloth, because the biodegradable plastic product is not water resistant. Well, this is the autograph test result of the biodegradable plastic product in original state. You can see that 122 provides the best result. It is 12.25 Newton, while the control is only 9.5 Newton. And for the elongation, 122 still provides the best result. It is 50.54 millimeters. But we can see that it don't have much difference with the control. And this is the autograph test result of the biodegradable plastic product after the treatment. You can see that 122 gives the best result. It is 7 Newton, while the control is only 3.5 Newton. And for the elongation, we have a surprising result. 128 gives the best result. It is 100.08 millimeters, while the control is 86.2 millimeters. But if we compare between control and the previous best, the 1:2 ratio, you can see that they don't have much difference in elasticity. So, overall, 1:2 ratio provides the best result in terms of strength and elasticity for both products, bioplastic and biodegradable plastic. How does chitin work? How chitin could strengthen the structure of the plastic? Does it bind to specific molecules? Here's the answer. This is the polymer structure. And this is the polymer after being reinforced with chitin. You can see that the presence of chitin nanofibers inside the structure of the polymer that strengthens the plastic. There are a few environmental benefits from this research. For example, we can utilize this scrap shell waste to form stronger plastic. We can also reduce the non-eco-friendly plastic waste because one of the products is biodegradable plastic. And for the bioplastic product, we can see that by mixing organic compound, which is chitin, with synthetic plastic, will allow the plastic to degrade easily, even though it doesn't lead to a complete plastic degradation. So the conclusion is, first, the crab shell waste can be used as a source of chitin and can be extracted using both extraction methods. However, the extraction method have not worked effectively because the extracts are not pure. And chitin can be utilized to increase the strength and the elasticity of plastic, with 1:2 being the best ratio for both product, bioplastic and biodegradable plastic. And the last one, I made a new hypothesis that chitin may probably increase materials resistance with water through the observation. So I observed this possibility. And for the future work, I have 3 things that I would like to try. The first one is the cross-linking using gamma radiation to strengthen the plastic more. The second one is the modification of the extraction method in order to work effectively. And the last one is to do further observation about the possibility of chitin could increase materials resistance with water. Okay, I'm Bastian, and that's all from me. Thank you. So the chitin doesn't bind to the polymer, but it forms fibers, nanofibers inside the polymer structure. It's, if we say that when we pull a single paper, it will be much easier than if we pull a double paper or triple paper. It's like the chitin forming another structure inside the polymer. That's what makes the polymer stronger than before.
So you mean chitin strengthen the molecule between the polymer, the molecule between the polymer, there is a force in it.
Yes.
So then when you add chitin, then
It's like
do you have a chemical there?
no, there are no chemical reactions between the chitin and the polymer because chitin don't bind to the polymer molecules. It's like chitin is forming fibers inside the polymer structure. Polymer is like a huge chain, and then chitin forming fibers along the polymer. It's like when we pull one piece of paper, it will be much easier than if we pull double paper. So chitin is like putting another structure inside the polymer. So it doesn't bind, and it's not forming new substance. It's still chitin and polymer. They don't have any connections for them.
So it seems like there is one layer of polymer
Yes.
and then there is another
And a
layer.
layer of chitin.
What kind of standard do you use for the tensile strength testing?
I'm not comparing with the plastic commercial plastic standard, but because it's really hard to compare with the commercial plastic, since they all have a very thin, they are all very thin, and I cannot make that kind of thin film, so I cannot compare to the commercial plastic.
I mean for the standard procedure, because the testing, tensile strength testing must be a standard process, testing process, because if you have the tensile strength 7 Newton and so on, that is how do you measure the tensile strength and so on. So you maybe in the future you can take one standard procedure for the tensile strength and follow the standard procedure processing.
The standard that I'm using is I try to control the size of the sample and also the thickness and the flatness of the sample. So it means that it's like they are not the thickness of the samples won't affect the tensile strength. If we know that something thicker will be.
Cara ngetes seperti itu
Ada
dari mana?
prosedurnya.
Caranya kok lebih kenapa nggak dibakar misalnya atau diapain?
So tensile strength is to measure when the plastic breaks.
Ya,
So
tadi
Ya,
Pak
oke.
tes itu standarnya dilakukan untuk ngetes plastik.
Ya, ya mungkin nanti coba dicari ya apa. Mestinya ada kok standar
Ya.
untuk ngetes plastik itu ada prosedur ya. Pak, mungkin lebih tahu ya. Dan yang kedua juga biodegradability. So that is also the testing procedure should be have on the biodegradability.
for the biodegradable plastic, I obtain the information from the product because it's a commercial product, and they write in the information sheet that it will be degraded 3 to 6 months after disposal. And chitin is also organic compound, so the biodegradable plastic should be eco-friendly according to the LD.
And the last, for the future, is very dangerous. Maybe if you would like to make testing with irradiation procedure or the gamma irradiation, because I think the procedure is very difficult to have some testing. So maybe it's not usable for the future work.
Di masa depan itu gamma irradiation akan besar-besaran.
Ya.
Dan itu bisa di tabbing aja.
Saya pikir mau di tempatnya mau ada.
Dan itu yang mahalnya kalau gamma irradiation, kalau temboknya harus tebal. Bikin dalam tanah aja, kayak sumur. Di sana ada source-nya. Dan murah kok.
Maybe just suggestion from the Pak Purba, because he is an expert of their material, can explain it.
Okay, then first, I just want to comment for the terminology, like the bioplastic and biodegradable plastic. We explained that bioplastic for the LDPE and biodegradable plastic from the cassava starch is plastic. Actually, it's like the wrong terminology because the LDPE is not the bioplastic.
Yes,
I know it's just the blend from the chitin and also the LDPE. So it's like the different terminology because the bioplastic is derived from the bio, for example the PLLA, it's come from the starch or sugar or something. It's bioplastic. So the terminology, my suggestion is should be corrected because this is not bioplastic or LDPE. Sure, you use the 18 from bio. Yes, this is not the bioplastic. This is just the blend. Conventional plastic LDPE with the chitin from the bioresources material. And then the second thing is from the tensile strength. You explained that this is when I saw from the unit. You wrote the tensile strength is unit. This is like the wrong unit because the Newton is unit for the force. So I think this is you put the data from the experiment using tensile strength like this data, and you get this scale. The Y scale is the not tensile strength. This is the tensile load, not tensile strength, and this is the extension. So I think it should be corrected. Or you just change the tensile strength with tensile load. And another thing, if you explain the tensile strength, you have to explain that what is the speed rate of the tensile instrument, UTM instrument. For example, like the 10 millimeter per minute or something, you have to check it. Because with different speed, it will has the different result. Okay? And also the previous question about the mechanism. He explained like have the another layer. I think this is the mistake because this is not make the another layer. In my opinion, it should be came from the chitin as the another material, new material. It came as the nucleating agent. As the nucleating agent, so the polymer will grow with more crystalline part. So that's why it will have a strong tensile strength or the tensile load. Okay. So first you have to define the difference between the tensile strength with the tensile load. The data that you saw is the tensile load, not tensile strength, because the tensile strength unit is Newton per meter square, or megapascal or gigapascal. You have to explain because it's really different. Okay, that's my comment.
For the mechanism of action, You said that it's like crystalline structure inside the polymer, so it means that it's also the chitin also not built with the polymer.
Sorry?
The chitin is not really binding with the polymer.
No, no.
Actually, that's what I'm trying to express in the illustration, but it's really hard to say that it's forming that kind of structure inside the polymer, because most people will think that it will bind to the polymer.
No, the mechanism is the polymer is long chains,
Yes.
like it's the irregular chain. So with the addition of the inorganic part or organic part as the nucleating agent, it will make the alignment of the polymer chains. The alignment polymer chain, it will form the crystal structure of the polymer. It's not fully crystalline, but make the polymer become the more semi-crystalline part. So this way it have the more stronger.
So is it correct when I illustrate it that way? Because I also found it in some literatures. That's why I.
No, because if you show with this mechanism, it's difficult to prove the mechanism. Because the simple way to show the mechanism is first you have to show with the SEM analysis how the chitin with the polymer miscible or not. Okay, and the second thing is by the increase in the crystalline part, you can check using the DSC analysis, and it will be more easy to explain. Because if the addition to new layer, how can you show the new layer? It's more difficult to prove. But the principle in the polymer composites, it stems from the increasing the crystalline part of the polymer, the addition of the another materials.
And for the terminology of bioplastic, do you have any suggestions or advice how I should say about the product, which is a mixture of LDPE and chitin?
The difference is like I will agree if you put the bioplastic for the cassava, because this is also the real bioplastic. It came from bio, and of course it's biodegradable. But from the for the LDPE, it's not bioplastic. It's just like the conventional plastic, petroleum-based plastic. But sure, you can improve the biodegradability because the addition of the organic matter from the crab. Right? So it's I'm not agree if you put the bioplastic for the LDPE because it's really different because this is the petroleum-based plastic.
And do you have any other words how to say that without using the bioplastic terms? How?
You can put the two terminology. One is the petroleum-based plastic, which comes from the petroleum. The example is LDPE, and the another one is the bioplastic, using the cassava starches.
Mixing plastic.
Or in the polymer, we can easily explain that this is the polymer blend. Blend.
Blend.
Maybe we can discuss later with Pak Purba.
Okay, we can discuss that.
Kamu lulus dulu dari SMA, belajar. Levelnya.
Udah tingkat di atas.
Belum dapat ya, siapa?
Gak apa-apa, itu
Gak apa-apa.
resiko dari penelitian Anda tuh yang nanggepin udah sampai level sana.
Itu.
Bagus
Harus tadi saya.
Ya.
Is it hydrophobic?
Yes, it is hydrophobic. Yeah, that's why there's a new hypothesis that it may increase the materials resistance reporters. Because there's data that shows with the addition of chitin, the tensile load reduction is lower before and after the addition.
Is crab the best source for calcium?
No, actually the chitin is like shrimp shell. It contains most chitin, but we all know that many people have been trying to utilize these shrimp shells, and I have read a lot of papers about utilizing preparation of chitin from shrimp, preparation of chitin from mushroom, but I never found anyone that thinking about using the crab shells. That's why in the place I came from Bali, I saw there's a lot of crab shells there. That's why I think that this might be another potential source of
I
ketamine.
thought you use crab because you like crab.
Yes.
You do.
Itu udah dilakukan juga. Justru apa juri-juri internasional di ICYS tuh ingat
Ya.
yang kita bawakan tahun lalu, makanya kita harus.
Ya.
Oke, sekian cukup. Terima kasih banyak ya.